Okay, so we're going to look at 10.1, 10.2, and 10.3 in this video. Very short videos, just how to graph an ellipse, how to graph a parabola, and how to graph a hyperbola. So there are two formulas here, x minus h squared over a squared plus y minus k squared over b squared equals to 1. And then x minus h squared over b squared plus y minus k squared over a squared equals to 1. Notice the only difference is a and b. The idea in one of them, or both of them, a is bigger than b. So in the first formula, a is bigger than b, or a is under the x. So it means it's wider to the side. X is horizontal, so it's wider horizontally. Here, a is under the y, and a is greater than b, so it's more vertically. So that's the only difference. So h and k is your center on both. You're going to go to the middle here, your center. Then there's going to be some values that are going to go right and left. You're going to end up going right and left, essentially these values here. Going essentially, because a lives under x, you're going to go a to the left, a to the right, and you're going to have what are called vertices, or you have values, essentially vertices on the ellipse. And you're going to go up b value, the number that's under the y. You're going to take the square root of it. You're going to go up and down that amount, and that's it. You're going to draw your ellipse. That's all it is. There's going to be some kind of c value that's going to be a squared minus b squared. C squared is going to be a squared minus b squared. And you're going to go that amount along the fatter part, which is called the major axis, and the thinner part is called the minor axis. So c to the right, c to the left, you're going to put two dots, and those are what are called foci. The idea generally, like if this is on a board and these are tacks, if you get these two tacks and you put like a rubber band, and you put you put the rubber band around both of them, and you put it on one of the point of the ellipse and follow the ellipse around, these foci will help make your ellipse. And in fact, it'll be proportional from two distances to that point. That's a whole other issue here. I don't really want to get into it too much. It's just those are called foci, or each one is a focus. Eccentricity would be the c value divided by the a value. That's essentially the amount of orbit, the type of orbit. That's what it is. It's some issue in astronomy and in other classes, but for us, it's just going to be a value that we're going to compute. Here, the same difference, because the a value, a squared, is under the y, you take the square root of it, go up a, down a. So the fatter part, or the major axis, is the vertical one. The square root of the b squared will be right and left under the x. The c value, again, will be the same as this c value here. And it'll be on the fat part. Your foci will be on the fat part of it, or what's called the major axis. So let me graph two of these, and let me show you what the heck I'm talking about. So in the first formula, x plus 3 squared over 4 plus y minus 1 squared over 16. Notice that 16 is bigger than 4, greater than. So it's this type of graph. So the larger value is under the y-axis, or under the y value. So it means y is going to be vertically bigger. So the b value is going to be the square root of 4, which is 2. The a value is going to be the square root of 16, which is 4. So because you take the square root of 4, you get 2. It means 2 to the right, 2 to the left. Because the square root of 16 is 4 and it's under the y, up 4, down 4. The center point is going to be these two parentheses. It's going to be the opposite sign. It's going to be h and k. So this is x plus 3, this is y minus 1. Negative 3, positive 1. Had this been minus 3 plus 1, it would have been positive 3, negative 1. It would be the opposite sign of them. So I go to the center at negative 3, 1, which is right here. Then because the b value is 2 and it's on the x, you're going to go 2 to the left and put a dot, 2 to the right and put a dot. Because the 4 lives under the y, it means from there up 4 to that dot, down 4 to that red dot. So those 4 dots, just connect them, and that's essentially your ellipse. So very simply, from the center, which is negative 3, 1, right 2, left 2, put 2 dots for vertices. Up 4, down 4, put 2 dots, vertices. Again, this is your major axis going up, your minor axis going sideways. Connect the 4 dots in a circular fashion. That's your little football, or your little ellipse. Now your c value is c squared equals a squared minus b squared. So 16 minus 4. That's 12. So c is the square root of that, so roughly about 3.46. So from this point, which is negative 3, 1, I'm going to go up and down 3.46. So that should put me at 4.6, and negative 2.6. So up and down, still right on the inside, right under the vertices on the major axis. And your eccentricity would be the C value, which is square root of 12, divided by the A value. The A value is 4. So 0.87. The closer that this thing is to 0, or sorry, the closer that this thing is, let's see, yeah, the closer that this thing is to 0, the more circular it is. The closer it is to 1, the more lopsided to one side or the other that it is. That's the type of orbit. This 0.87 is almost close to 1. This is pretty lopsided, so to speak, more football-ish. The closer it is to 0, the more circular it is. The number 2, x minus 2 squared over 25 plus y plus 3 squared over 9. Notice that 25 is greater than 9, so it's going to be more fat horizontally, more like the first one. So a squared is 25, so that means a is the square root of that, which is 5, which means it's under x, so right 5, left 5. 9, I went to the square root of that, which is 3, so that means up 3, down 3, because under the y. My center is positive 2, comma negative 3. So I'm going to go to the point 2, negative 3. I'm going to go up 3, down 3, put 2 dots. I'm going to go left 5, right 5, and I'll put 2 dots. And that's my ellipse. That's all it is. So at the point 2, negative 3, go 5 to the right, put a dot. 5 to the left, put a dot. Go up 3, put a dot. Go down 3, put a dot. And connect it, and there's your ellipse. The fatter part, the major axis being the horizontal axis, I'm going to find my C value. So C squared is A squared minus B squared. So bigger minus the smaller. So 16. C is the square root of 16, which is 4. So it means from this dot, go 4 to the right. So if I'm at 2, negative 3, I'm sorry, if I'm at 2, negative 3, and I go to the right, 4, this becomes 6, negative 3. If I go to the left, essentially that's negative 2, negative 3. Yeah, I just have to make that correction here. This is negative 2, negative 3, and that's 6, 3. Again, to the right 4, to the left 4. So that their vertices, this net vertice is at negative 3, negative 3. The focus is at negative 2, negative 3. The eccentricity is C over A, so 4 divided by 5, so 0.8 or 0.80. And that's all it is. I just did 2 quick examples of ellipses because essentially that's all that is. So now hyperbolas. Hyperbolas are very similar. You see, instead of going like this, you're going to go against the grain. It's going to be opposite of itself. So here, instead of the ellipse being inside this box, we're going to go the opposite direction. We're going to open the ellipse up in both directions. Instead of the ellipse being this way, it's going to open up and go the other way. So instead of being like this, I'm going to split outside. And that's what you're going to get. You're going to get it going outward. So it's like, imagine these two things kind of brought back in. It'll be an ellipse. Outside, it becomes a hyperbola. The two formulas, it's y minus k squared over a squared minus x minus h squared over b squared equals to 1. And I'm sorry for the scribbling here, but x minus h squared over a squared minus y minus k squared over b squared. Notice that it's x squared minus y squared. So if it's x minus y, if it's x squared minus y squared, it's along x, it's horizontal. If it's y squared minus x squared, it's vertical. So if it's y's minus x, it's up and down. If it's x's minus y's, it's right and left. That's the difference. The A will still stay on the one on the left. The B will stay on the one on the right. In this case, it doesn't matter that A is bigger than B or A is less than B. A and B could be the same. A and B could be different. One could be bigger than the other, whichever order you want it to be. Except now the C squared is A squared plus B squared now. So we're going to add A squared plus B squared. And the eccentricity is still C divided by A. The center is still going to be HK. It's still going to be the opposite. And I'll show you that. I'll do a couple of examples down here in a minute. So the only difference now is this. Because of y minus k, essentially if the A is under the y, this means up A, down A, and this means right B, left B, like we did before, except before we would make a little football here. But instead of making a football, we're going to make a little box out of this thing. We're going to connect the diagonals of the box, and we're going to put the hyperbola above and below that box, at the lowest point of the box and the highest point of the box. These dotted lines are what are called slant asymptotes, or what are called oblique asymptotes. Okay, these are where the graph cannot touch. Same thing here. We're going to go right, left, essentially A values, up B, down B. We're going to connect the dots diagonally through a box, and we're going to put our hyperbola horizontally. Let me show you what I mean in a second here. X plus 2 squared over 9 minus y plus 1 squared over 16 equals to 1. So this is where x squared is minus y squared. So it's going to be this case, left and right. So you can see my final graph there. That's what I'm getting. Let me explain how I got there. So the a value, a squared is 9, b squared is 16. So I take the square root of both sides. I'm sorry, I take the square root of 9. I take the square root of 16 respectfully. So a is 3, b is 4. Since 3 lives under the x, it means right 3, down, left 3. Since 4 is under the y, it means up 4, down 4. My center is my x value followed by my y value. Opposite, opposite. Opposite sign, opposite sign. So negative 2, comma, negative 1. So I'm going to go to the point negative 2, comma, negative 1. From there, I'm going to go right 3, left 3. I'm going to go up 4, right 4. But instead of drawing my ellipse connecting the 4 dots in a circle, circular fashion, I'm going to make a box out of this. I'm going to go up, right, up, and left. So make a little box. I'm going to connect the diagonals of a box with what are called dotted lines, what are called asymptotes. Because this is x squared minus y squared, I know this point in the box and this point in the box become what are called my vertices or vertex of each. So I connect, I put my 2 dots here, but now it's going to be like it's going to be like essentially like what's called a parabola, which we'll do in 10.3, which is weird. I don't understand why we didn't do parabolas first in this chapter, in the way the book is set up. But anyway, you go parabolic, you go in this fashion along the asymptote. And that is one half of the hyperbola. And then this one you go along the other one, which is the other asymptotes, which is called the other half of the parabola. From this box, we're going to go along this axis, the c value. So c value is a squared plus b squared, so 9 plus 16. The c value is the square root of that, which is 5. So from this center, negative 2, negative 1, I'm going to go right 5, left 5. So I'm going to be at positive 3, negative 1, and negative 7, negative 1. So those my foci are inside the paths of each parabola. My eccentricity is 5 c over a, 5 over 3. So this one is going to be bigger than 1. So the bigger than 1 means that these things are opposed to each other. So you have 2 orbits. So it's greater than 1. It's outside of the 1. The closer it is to 1, the closer these are together. But for the most part, you want to have it greater than 1. I'm sorry. The closer it is together, the further they are apart. But nonetheless, that's okay. That's not important. It's just eccentricity is 1.67 here. And this one is y minus 3 squared over 25 minus x plus 1 squared over 4 equals to 1. Now, notice that it's y squared minus x squared. So it's the vertical type. So some people would say the center here is 3 comma negative 1. But the y value is always second. So this is 3 for y and negative 1 for x. So negative 1 comma 3 is your center. Your a value is 5 because it's square root of 25. Your b value is 2 because it's square root of 4. Because a lives under y, it means up 5, down 5. And because b is under the b is under the x, it means right 2, left. So from the point negative 1, 3, go right 2, left 2, up 5, down 5. Because this is vertical, I'm not going to put an ellipse here. Not in the middle. I make a box around what would be the ellipse. Connect the dots diagonally, connect the diagonals, and then the hyperbola, the top of this box and the bottom of these boxes, we what are called vertices or vertex. Vertex of each, singular. So now I'm going to draw this as if like a happy face going along the asymptotes, and a sad face down here going toward these asymptotes. My c squared is going to be a squared plus b squared, so 25 plus 4 is 29. Square root of 29 is about 5.39 roughly. So from the point negative 1, 3, I'm going to go up 5.39, which is going to put me up at 8.39. I'm going to go down 5.39, which is I'm going to subtract, so I'm going to get negative 2.39. So those are what I call my foci. And these are just a couple of examples of what it means to be a hyperbola. It's a pretty nice concept, pretty easy. You can review essentially the notes here. And again, keep in mind those formulas. Hold on to those formulas. Don't lose them. Keep them. Write them down somewhere. And so that was 10.2. So 10.3 is your parabolas. So the idea of all of this that we've been doing what we've been doing is called a conic. So what they do is they take kind of like a hourglass type of thing. If you cut vertically up and down, and you take a cross section, you get your little hyperbolas. If you go sideways here, side to side, you get your ellipse. In fact, you get your circle. I guess you got to do the ellipse diagonally, but nonetheless, that's your little egg. Your parabola is only like the top half or the bottom half of the hourglass vertically. That is your parabola. You can go diagonally as well. It doesn't matter. So parabola, there's four types of parabolas, and they're basically two equations. These two, x minus h squared equals 4p times y minus k, and y minus k squared equals 4p times x minus h. So notice that in this case, only one of the variables is squared. So in this case, only the x is squared. So it's essentially weird because if it's y and x squared, if it's x squared, it means up and down. If the x is squared, you're going to go vertical. If the y is squared, you're going to go horizontal. The reason is when y is squared, this is essentially x to the first. So x essentially dominates horizontally. When x is squared, essentially like the y dominates. So up and down. So depending on this value here in front, whatever's in front of the y, the first here, not the one that's not squared, the first power of y, if it's positive, it goes up. If it's negative, it goes down. Over here, if the number in front of x is positive, it goes to the right. If the number in front of x is negative, it goes to the left. I'll explain what that p-value is in a moment. Okay, this is the idea of p, the number of p units. So whatever this value p turns out to be in the problem, which, again, I'll show you through some examples. The idea is wherever the vertex is, again, the vertex is the point h and k. It's like the center in the ellipse and in the hyperbola. H and K is the center. In this case, it's what's called a vertex. It'll be either the highest point or the lowest point, depending if it's going up or down. The leftmost point or the rightmost point, depending if it's going right or left. From that vertex, we're going to go up p units, down p units. One of them's going to be a dot, and one of them's going to be a dotted line. Inside the parabola is going to be a dot, which is called a focus. Outside is going to be called a director, so it's going to be perpendicular to the line going right down the middle. So wherever the vertex is, or whichever way that the parabola goes, we're going to put a line going up and so if the parabola goes up and down, we're going to run a line right through the middle, right to the vertex, which is a vertical line of symmetry. If this guy goes side to side, we're going to run right through the vertex, right down the middle, which is going to be a horizontal line. The directrix will be a line perpendicular to the line of symmetry, p number of units to one side of the vertex. The focus will be p number of units inside, essentially the parabola. The directrix will be the outside of it. And I'll show you what I mean in a minute. Let me walk you through a couple of these to kind of explain this. So here's the gist. This is x minus 3 squared equals 8 times y minus 1, y plus 1. So here it's x squared equals to something with y. So x squared equals something with y. We know it's going to be up or down. So we take the number here in front of the parentheses, in front of the y. That's 8. That's understood to be 4p. So 4p is going to equal that number, whatever it is. So the p value, we divide both sides by 4, and essentially p is 2. Because this is a positive number, it's going to go up. If this was a negative number, it will go down, depending on how the graph is. The vertex, you would take the opposite sign and the opposite sign, like we did with the hyperbola and the ellipse. So positive 3, comma negative 1. From that point, 3, negative 1, we're going to go up to, because this is opening upward, we're going to go to the point 3, comma negative 1. We're going to draw a happy phase. We're going to draw a parabola going up. Now, where you cross the y and x axis doesn't really matter to me. I don't need perfection here. Now, I think the software, the homework might ask you for the x and y intercepts. In that case, you would solve a quadratic using your college algebra skills. So you can figure out this more in detail. But for me, I'm okay with this. Just kind of graph this way, up and down. Now, from the line of symmetry comes right down the middle. So you cut the parabola in half, right down the middle, dotted line, that's your line of symmetry. And along the center, this point 3, -1, we're going to go up 2 spots. And we're going to put a focus in the inside of the parabola at the point 3, 1. We're going to go down 2 spots where the x value is negative, the y value here is -3. And we're going to draw a dot. So we're going to go up, down 2, up 2. When you go up 2, you're going to put a dot. When you go down 2, you're going to put a line perpendicular, dotted line perpendicular to the line of symmetry. We just call it directrix. The idea is anywhere along this line, anywhere along this graph, the idea is if I'm at a point of the parabola, the distance from the directrix to the parabola and the focus of the directrix, focus of the parabola should be about the same. And there's a whole issue with physics involved in there, but for us, it's just going through the motions. Okay, how do you find the focus? How do you find the vertex? How do you find the graph? How do you find the vertical line? How do you find the horizontal directrix? So again, the point 3, -1, up 2, down 2. The parabola is vertical because x squared equals to y. So parabola is, and it's going up because the p-value is positive, or this number is positive. So up and up. Up as a happy face. Up 2 units, focus, down 2 units, directrix. Line of symmetry runs right down the middle. This is now y squared equals to something with x. So the y is squared and the x is over here by itself. This number is negative. So first of all, because y squared, we know it's going to go side to side. We're going to go either to the right or to the left. Because the number in front of the x is negative, it means go left. This one. If the number here had been positive, it will go to the right. So it tells you what direction to move. And that's why my guy is going left here. So my center here, there's no opposite sign, so there's no parentheses here. So we say that the y value is 0. The x value is -4. So my vertex is -4, 0. -4, 0 right there. Because I know it's going to move left, I'm going to draw a face to. I'm going to draw a side face to the left. I'm going to draw a face going left, or a parabola going left. So now, right down the middle is the x-axis. That is your line of symmetry. So the only thing left to figure out is what's p. So because this is 4p in the formula, -12 equals to 4p divided both sides by 4. P is -3. So it means left 3, right 3. Inside the parabola is this point called the focus at -7, 0. At -1, 0. Instead of putting a dot there, I put a dotted line vertical because that has to be perpendicular to the x-axis. That's all this is. And essentially, this is how you graph a parabola. So this chapter is very straightforward. We learn how to graph ellipses, hyperbolas, and parabolas.